Abstraction is this idea when you take something very complicated, you add an interface on top of it, and you give people that interface so that they can use it. And the people using that interface don't have to understand all of the details of your system. For example, if you take a simple coffee maker, probably have one button to make coffee, you press it, but you don't have to be an electrical engineer to use a coffee maker. In computing system, we have many layers of abstraction. In this video, I'm going to talk about some of the layers of abstraction that exist and also talk a little bit about some of the interface that they expose. The first layer we're going to talk about is people. As you know, software are written by people. And you as a person, you're actually part of a layer system, right? You work with team, and usually a team of software engineer would probably have 3 people that are regular software engineer, and you're gonna have a tech lead, and also sometimes you have a product owner or project manager. This layer, these are the people who knows how to interact with the computer to actually code the thing. Above, at this layer, you're probably gonna have manager, or if you don't have a manager, you're gonna have a client. You're gonna have some people who have some problem, and they will tell you the problem. Those people don't know, or sometimes they do know how to solve it, but they would rather you solve it for them. So you as a person, you offer interfaces, right? Teammate can come and talk to you and ask you question. So instead of a teammate going and read the code, they might find it easier they talk to you, and then you talk back to them. And when you talk back to them, usually you don't talk to them in computer code. You're not going to tell them you're not going to go and then take the main function and then read it to them, back to them. You're usually going to explain them the thing in a language that is very easy for them to understand. So the ability of taking something complex, which is the source code, and explain it with real word in a domain that they understand, this is your abstraction. For example, if your code is responsible for, I don't know, creating invoice, you're going to tell them, so when you come to the application and then you click this button, it's going to create an invoice. But you're not going to tell them any detail related to, oh, this invoice system is written in Python or Java or C++, right? A lot of people having the ability to take something very complicated and explain it in a way that can abstract the details and communicate with someone else, it's a really important skill. And it's one of the most important skills that you can have. It's the ability to explain that complexity to people that will help you forward and go at a higher level of the abstraction layer. Right. And one thing also to understand is there's always a layer above, right? And you can always keep on going on layer above, and nobody knows what is the topmost layer because there's always something above. And also the same way, there's always a layer below, right? You can keep going down and down and down. All right, let's go down a layer below. At this layer, you're going to have the application, right? So you're going to have the app. Usually the app has a user interface, right? And the user interface would have button, or sometimes it's a command line interface where you can type something and press enter, right? And then the app would take this information and then go down again a layer below and get that information and give it back to you. For example, if you have a web app, you go into the UI, right? And then you click button, and then this click will eventually give you back the message that you want. At this layer, usually the people working at this layer, you're gonna have the UI and UX people. So these people can create the user interface for you. So these people creating the user interface, they usually interact with applications such as, if it's a web application, it's probably gonna be a combination of JavaScript. It's gonna be a combination of JavaScript, CSS, and HTML. For now, we're going to assume it's a simple web app, right? So you're going to have the UI and UX people who are going to do research. They're also going to talk to a lot of people to understand and knows what works and what doesn't work. And then some engineers that knows how to that knows how to interface with the web browser via JavaScript, CSS, and HTML would create a nice design for you so that when someone is using the application, again, they don't have to understand the details on how the web browser works. They can just work with it. Most applications have a backend system. So this is still, this entire layer is still the app, right? This is still the app layer. Most application, when you have the UI, assuming, well, for now, we just, to make it simple, we're gonna say that we're using a web app, right? Like a web application that is hosted on the internet. And for simplicity, also, I'm gonna remove all the networking and stuff like that, just simple, like a binary that's always they have a UI. So you have this layer of the, usually they call this the business layer. That's where you have all of the logic, right? And depending on the type of application, you have a variety of tools that you can use to communicate with the layer below, right? That's why you have different programming languages. You would have programming languages that are specific for certain tasks and that make it easier to do certain tasks compared to other programming languages. For example, some programming languages abstract away a lot of details for you so that you don't have to worry about knowing the thing below. If, for example, using a programming language such as Python, you don't have to worry about memory. You don't have to worry about pointers. You don't have to worry about a lot of things. And this is, again, part of abstraction. It's this idea that removing the details so that you as the engineer just worry about the things that are important to you and let someone who is at the lower below to take care of all those details that you don't want to deal with. So usually the business layer has things such as the rules of how the system should work. For example, at a business layer, you may have rule for your invoicing system so that when a user creates an invoice system, they have their address fetched from somewhere. They have the amount that the user needs to pay. They have all of those extra things. So this is the business layer. One layer below the business layer is the data layer. The data layer is usually made of, like it says, an abstraction on top of the layer below that has the rule on how to save information for the long term so that you can retrieve information that is saved, right? You can easily save information and easily retrieve that information again. And this abstraction, if you didn't have an abstraction on top of it, it would be something very difficult to do, right? Even though you have access to the operating system disk, if you have to write the program that will save things on the disk each time, it would be really confusing. Usually the data layer, you're gonna have all type of databases, right? You're gonna have, there is an area of databases. So depending on the application above, usually I would say there are 3 types of database. You're gonna have document database. You're gonna have, there are also sometimes a graph database, right? There is also sometimes you have relational database. So each one of these type of database offer services that make it easier for your app. For example, if you're writing an app that fit well with a hierarchical structure, right, you may find it easier to use a graph database. So instead of you knowing all of the details on how the graph database work and all those things, you just pull a graph database. A lot of applications use the relational model because the relational model make it easier for to have relation between tables. And a lot of people find it very easy to use it, but no one is going to sit down and write a database application, right? Instead of writing a database application, you just take a database up off the shelf that abstract away all of the interaction that has to do with saving things on disk or removing things on disk. And also at this layer, there's another layer down here that's called the infrastructure layer. So let me put this here. So you have an infrastructure layer, right? So the infrastructure layer here is things you have such as accessing short-term memory. You have caching, right? If you have caching, right, you would have things related to networking, like how do you send data over a network so that you don't have to worry about networking related tasks, message passing, and also something at this layer you have. Those are still things on top of the operating system. Like you don't have to know those detail about how to do it, but this layer can help you with this. And sometimes you also have Docker. A lot of professional in the past few years have been using Docker. Again, Docker is an abstraction on top of the operating system that can help isolate your application so that other programs in your operating system don't get access to things they shouldn't get access. So Docker would create an abstraction for you on the hard drive. It's going to create an abstraction for you for memory. It's going to create an abstraction for you for the entire Linux kernel. And having Docker make it easy to transport your app from one computer to another computer. So you have the Docker. So this is also part of the infrastructure layer, right? It's a combination of Docker and all those things. At the bottom, you have the operating system. The operating system, it's a layer that is on top of the hardware. As a software engineer, sometimes I just want to save a file, but I don't care about how the file is saved. I don't care if the file is being saved on a hard drive where I have to manipulate the disk and move the disk. So usually hard drive is like a disk, and then you have like a needle, and then the needle has to move at a specific location, and then to save the data, and then finding the best way to save the data so that the disk is not fragmented. As an engineer, sometimes you don't have to worry about all those details, right? So you have the operating system layer. Usually the operating system is written in C, because again, this tool make it easier for you to have more control over the hardware. And you will have a tendency, like all of those things that is on the infrastructure layer, they are written in programming language such as C, Golang, right? They are written in programming language that knows how to access pointers, and they are very good at accessing things that more complicated, but yet give you more performance. So this layer, you're gonna have C, you have Golang, you're gonna have assembly, like on the operating system, something is written in assembly. So if you can see, the more you're going down the OS layer, the more you're going down the layer architecture, the more power you have, but the longer it takes and the more skill you need. And if there isn't an error at the bottom layer, it's going to impact the entire stack. So when there's a bug here, the bug in the OS is going to impact the entire stack. So the more you're going down, the more skill you need, and the more time you need to spend reading book and reading detailed technical documentation, and probably the more education you need, right? The operating system, even the operating system is just a piece of software, but then down here, you have the hardware. Right? The hardware, again, is very difficult. And as you're getting more down here, now you going to a realm where most of the people working at this layer, they are probably computer and electrical engineer. At this skill level down here, you have a lot of people who not only understand how to write computer code at a at a higher level, but they also understand electricity. So the people building hardware, they're most likely going to be electrical engineer. So this realm, as you keep going down, right, you need way more skill. It's way more difficult. Now at this layer of hardware, you're going to have to understand voltage. And at the hardware layer, then you also have to create interfaces so that people who are building the operating system can read the interfaces and piece it together and write something that makes sense for them, and then expose these interface up here so that people who are writing infrastructure can use those. For example, there is something called Puxis, Puxis. Puxis, it's a list of interface that an operating system would expose so that people who are writing app can interface with those Puxis compliant things, and then they will get the result. For example, it might tell you, oh, if you want to write to this is the function and this is the parameter that is needed, but the details on actually, are you writing in a hard drive or you're not writing in a hard drive, Well, one thing that I forgot to mention, even the OS, you can also have a layer down here. This is called virtualization, right? A lot of cloud computing, they use the virtualization layer. In the virtualization layer, you're talking things such as VirtualBox or some other virtualization that allow you to have one hardware and then have different type of operating system running on them. In cloud computing, this is a very powerful concept where you just buy one computer and then you can have a Windows operating system running, you can have a Linux running, different distribution of Linux. Layers goes down up to the electron layer. And nobody can knows all of those layers very hard. And every layer, each layer has a lot of component. So not only you can go down the layer system, you can also go to the right or to the left. When I say to the right, to the left, for example, if you're a hardware layer, you have GPU, right? The GPU itself is the same thing. They abstract away a lot of things so that you can work with drawing things on the screen. They can also do a lot of matrix calculation, but they expose this so that someone who's writing OS or someone who's writing an application can just use it, but they don't have to understand how electricity travels. Eventually, you're gonna get electrical engineer as you go down the layer because all of these want electricity. You want electricity for all of this. And electricity, at that one, you're no longer a computer person. You're someone who knows how to make electricity. And even the people who knows how to make electricity, there are a lot of layers for them. And like I said before, nobody knows what's going down the deep layer. You will get to a point where you need people who understand quantum physics to understand how electricity works or to take advantage of certain things. And at this layer, I don't have enough experience to explain this because I don't know it. This being said, now, knowing where you fit into the layer and the tools that is used at this layer can really help you, right? And knowing the type of class that you need to take as a student and kind of identify where exactly the layer, what exactly skill is needed for that particular layer would help you. So I hope this kind of give you a big picture on all of the layer system. If there is a specific, I'm gonna spend more videos going into more detail into specific layer in the future. And if this is the type of video that you like, subscribe to this channel and I'll see you next.